Lying down on the table is a Foxboro Model 13A differential pressure transmitter. This particular pressure transmitter is pneumatic. It has no electronic components whatsoever. It receives a supply pressure of approximately 20 psi clean instrument air and provides an output pressure ranging between 3 to 15 psi of clean instrument air, representing the process that it is measuring. Like all differential pressure transmitters, it has two ports, a high pressure side and a low pressure side. On this particular model of transmitter, you can see high and low are marked with large letters that are unmistakably cast into the metal itself. So over here we have the high side, and over here we have the low side. This device is built to respond to a difference of pressure between those two sides. An increasing pressure on the high side drives the output signal of this transmitter up. So being a pneumatic 3 to 15 psi signal, an increasing pressure on the high side will drive that signal up towards 15 psi. An increasing pressure on the low side, conversely, drives the 3 to 15 psi pneumatic signal down. So an increasing pressure on the low side drives the pneumatic output signal down towards 3 psi. If we look at the label on the side of the transmitter, we see some interesting information. It's useful to us, and although it's specific to this particular transmitter, these general parameters are common to all differential pressure meters. You see, again in large, bold letters cast into the metal, 1500 MWP, maximum working pressure. That refers to the maximum gauge pressure that we may apply to the capsule and still be within its engineering limits. This is a safety limit. This is not the measurement range of the instrument. Remember, the instrument responds to differences of pressure between high and low. This maximum working pressure value is not necessarily a differential pressure, it's a gauge pressure between either one of the ports and atmosphere. For this particular transmitter, what we have here for a range, it says 0 to 50 inches of water. So that is its maximum range of measurement, 0 to 50 inches of water. Now, recalling that 27.7 inches of water is equivalent to 1 psi, we're looking at a range of almost 2 psi. 0 to 2 psi differential. So even though the housing, the framework of this transmitter can withstand a gauge pressure of 1,500 psi maximum, it only responds to a maximum of about 2 psi of difference between the high and low ports.